So which set of coefficients balances this equation? Okay, so we'll look at, here's 2 carbons, so I'm going to need 2 CO2s, and I'll say 1 there. Now I have 6 hydrogens, so 6 hydrogens and 2 hydrogens, I'm going to put a 3. Okay, that'll give me 6 and 6. Now oxygens, I have 2 times 2, here's 4 oxygens, 3 times 1, 3 oxygens, so that's 7 oxygens, so this is going to be 7 halves O2. Now, if there was an answer like that, I'd be done, but I'm not. So I'm going to go ahead and double everything. So I'm going to call it 2, 7, 4, and 6. I'm looking for 2, 7, 4, 6, and there it is, answer D. Okay, when the equation for the combustion of propene is balanced with the lowest whole number coefficients, what's the coefficient of oxygen? Okay, so this is the same question, same type of question. It's just making me do a little bit more work. So I have to put in oxygen. I'm going to do CO2, I'm going to do H2O, and I've got, it's kind of sloppy, that's a 3, so I have 3 CO2s. I have 6 hydrogens, so that's going to be 3 H2Os. 3 times 2, that's 6. 3 times 1 is 3, so that's 9 oxygen, so 9 halves oxygen. So when the equation is balanced with the lowest whole number coefficients, okay, so I may have to double. So my answer is going to be 2, 9, 6, and 6. Those are my coefficients. And so the answer they want is 9. Answer B. Okay, when an alcohol reacts with carboxylic acid, okay, that's just memory. You should know that we did that in class. We did methanol, we did salicylic acid, and we made an ester. And that's the one that smelled like wintergreen. Okay, what's the formula for the ionic compound form when sodium ions and sulfide ions are combined? So we know sodium is Na+, we know S-sulfate is 2-, so I'm going to need to have 2 sodiums to balance out the charge on the S2-. I'm looking for Na2S, answer A. In the compound, what's the name of the positive ion? Okay, well this is using a little bit of logic. If it's SN, that could be 2+ or 4+, stannic or stannous. Okay, and I have sulfate, but I have 2 sulfates. Now, sulfates are always -2, so in this case, this must be a 4+. So this must be the stannic ion, okay? Or it could be tin 4 if they have that as a choice. Okay, 55. The unknown element X forms a salt with XO2, which could be X. Okay, well, if as XO2, okay, now O2, I mean, each O is 2-, so I need something that's 4+. It's got to be that one. Okay. The other ones will give me different formulas. Okay, 56. Which of the following is the correct formula for calcium phosphate? Okay, we know our ions. Calcium is 2+, phosphate PO4 3-. So if I have 2+ and 3-, I'm going to need 3 calciums, and I'm going to need 2 phosphates. So something that looks like that, Ca3PO4 taken twice. Okay, what's the correct name for CuSO4? Okay, again, sulfate is, we know that that is 2-. Okay, so the copper must be the 2+ ion. So that's copper 2 sulfate or cupric sulfate. Answer B. What's the name for N2O3? Now these are nonmetals, so it's going to be dinitrogen trioxide. Dinitrogen trioxide there. No, that's nitride. Dinitrogen trioxide. Answer B. 59. In a sample of salt water, salt is the, okay, well, water is the solvent, and salt is the solute. Solute. Answer B. Okay, which of the following compounds is expected to be soluble in water? Okay, we can use our chart and just have to look up and which one on our chart says aqueous. Okay, and when we do that, we're going to find out that it is SRBr2. Okay, so we're going to actually have to use that chart that's given on the back of the periodic table and look those up, and that's the only one. All the rest are going to say solids. Okay, SRBr2 is going to say aqueous. 61. How many grams of sodium hydroxide pellets are required to provide 50 milliliters of 0.15 molar solution? The molar mass is given. Okay, so this takes a little bit of time. This is a molarity problem, and we're going to use our molarity triangle. So molarity is moles over liters. Okay, kind of sloppy, sorry. And what do we know? So I'm going to do the whole IESA thing here. So I have N, and I'm going to have molarity, and I'm going to have volume, or liters. So I have 50 milliliters, which I'm going to change that to 0.050 liters. Remember, this kind of problem, I have to do liters. And molarity is given as 0.150 molar. And the number of moles, okay, number of moles, I'm given grams. No, I want to have grams, okay, so what I'm going to do is calculate my moles, and then I'll change moles to grams in a minute. Okay, I want number of moles, so I need number of moles is molarity times the volume. Molarity, we said, is 0.150 times 0.050 liters, which is 0.0075 moles. And I want that number, 0.0075 moles, times, okay, the molar mass, which is for every 1 mole, it's 40 grams. So when I multiply this by 40, I get 0.3, answer 0.3. Here it is, answer A. So it's kind of a big math problem, but it's worth a point. Okay, 62. If 50 milliliters of 200 milliliter sample of 0.1 molar sodium chloride is spilled, what's the concentration of that remaining solution? Okay, that's that tricky question we talked about. If you spilled some solution, what's the concentration of what's left over? It's the same thing. So if it's 0.1, then it's still 0.1. Now a different question, if you would spill some and then added some water to make up for it, then you would have diluted the solution. But this is just, reading carefully. Okay, list the following solutions prepared with the same in order of increasing concentration. So solute solution, increasing concentration. So the first one, we got 30 grams in 240, 30 grams in 120, and then 60 grams in 120. Okay, so the first one here, I have a bigger volume, okay, 240, and then I have 120, and I have 120. This helps me think. The first one I'm going to put 30, second one I'm going to put 30, and the third one I'm going to put 60. I'm having a hard time drawing dots. Okay, so certainly this one here is going to be the most concentrated. Okay, the second most concentrated would be this one, and the least concentrated would be that one. So I want to go in order of increasing concentration. So 1 is less than 2 is less than 3. That's answer A. 64. A 100 milliliter sample of solution with a concentration of 5 molar is diluted to a new volume of 400 milliliters. The new concentration will be. Okay, so this is a very straightforward dilution problem, and the dilution formula is volume times molarity before you dilute it is equal to the volumes times the molarity after you dilute it. So what do I have? 100 milliliters sample of 5 molar, so 100 times 5 molar is equal to 400 milliliters times X. So divide both sides by 400. And my answer is going to be 1/4 of 5, or 1.25 molar. Answer A. Okay, property of acids. Okay, acids are caustic. No, that's a base. They feel slippery. No, that's a base. They neutralize water. No, that doesn't make sense. They taste sour. Yes, acids taste sour. Okay, which of the following common solutions is basic? Okay, so lye, we tested that. Drain cleaner, that's the one that turned yellow. Okay, rubbing alcohol was neutral, and the other two were acids. Okay, the solution tested with cabbage juice turns green. Okay, which of the following is pH? Okay, green means it's basic, because pink was acidic, and pH that is greater than 7 is basic. So we need an answer greater than 7. That's the only answer greater than 7. This would be neutral, and these would both be acids. A solution conducts electricity very well. Okay, so that is a strong electrolyte, something that conducts electricity very well. A solution. Which of the following is considered a strong electrolyte? Okay, now this is just from what we've done. Okay, and a strong electrolyte would be a strong acid, a strong base, or a very soluble compound. Well, water is a very weak electrolyte. Sugar, that's a non-electrolyte. Okay, HF, that is a weak, and we can tell that because on our chart it lists the strong acids. So if it was like HCl, that would be strong, but HF is weak. KBr, that's soluble. If you look it up on the chart, it'll say aqueous, and aqueous things are strong electrolytes. K70, a substance that turns cabbage juice blue, so it's a base, and it lights up slightly. Okay, so slightly lights up, that means it's going to be a weak base. So we need a weak base. Here it is, answer D. Okay, which of the following represents the dissociation of calcium iodide? Okay, calcium iodide is ionic, and it's going to break up into calcium, which is Ca2+, and 2 iodide ions. So we're looking for something that's calcium 2+, 2 iodides, and that's this one. Okay, we need the arrow that goes there. 72, the acid 8ClO3 is named. Okay, well, we have to know that ClO3 minus is the chlorate ion. Okay, so since it's 8, we're going to take that off and put on ic acid. So we're looking for chloric acid. Chloric acid. Answer A. Okay. 73, hydrosulfuric acid. What's that? Okay, well, hydroic acid means it was an ide, so we're looking for sulfide, which is S2 minus, so we're looking for H2S. Acids are substances that increase the H plus ion concentration. So that's the one we want, increase the H plus ion concentration. Okay, 75, which chemical is a Bronsted-Lowry base? Okay, a Bronsted-Lowry base is somebody that accepts a proton, and here we can see that the H plus, which is a proton, goes to the NH3. That is our Bronsted-Lowry base. Okay, so NH3 is the Bronsted-Lowry base. 76. A solution has a OH minus of 10 to the minus 3. So what's the pH? Well, 10 to the minus 3, so we know that the POH is 3, and we know that pH plus POH adds up to 14. So the pH is 14 minus 3. It's 11. And that makes sense because this has got a lot of OHs, so it's going to be basic. So the pH is 11. Okay, what is the OH in a solution in which H plus is 1 times 10 to the minus 6? Well, if this is 1 times 10 to the minus 6, okay, which is a pH of 6, this guy must be 8. So this is 1 times 10 to the negative 8 for the OH minus. And that is answer C. Because when you multiply together, you get 1 times 10 to the minus 14. Okay, single replacement. Single replacement, we're looking for an element, compound, and that looks like answer A. Okay, this one here would be synthesis. This is double replacement, and that is decomposition. Okay, an acid was neutralized by the following reaction. Okay, how would we classify? Here's a compound, and a compound turns into a compound and a compound. Everybody's changing partners. The H and the OH forms water. Na and Cl forms NaCl. This is double replacement reaction, answer B. 80. When solutions of potassium sulfate, calcium bromide are combined, which of the following precipitates? Okay, so potassium sulfate, okay, so that's K plus and SO4 2 minus. And we got calcium bromide, Ca2 plus and Br minus. So we're going to make two new compounds. We're going to make one with K plus and Br minus. And we're going to make one with Ca2 plus and SO4 2 minus. So the two compounds are KBr and CaSO4. So that's part of the question, but the other part is who's going to precipitate, who is going to be solid when you look it up on the chart. And if you look these up on the chart, you're going to find out KBr is AQ, SO4 is solid, so this is the one that precipitates. If it says what forms, both of these would be good answers, but if it says which one precipitates, we're looking for who's a solid. And CaSO4 is the answer. 81. Which of the following are products when magnesium metal is placed in hydrochloric acid? Okay, well here we have a element and we have a compound. Okay, and this is just like our ornament lab with the zinc. And so we're going to single replacement. So the magnesium replaces the hydrogen, so we get hydrogen gas, and we get magnesium chloride. And we'd have to double that. So which of the following are products when the magnesium? We're looking for H2, we're looking for MgCl2. Okay, the only good answer there is D. Okay, when the equation is balanced, what's the coefficient? Okay, so here I have 3 H's, 3 H's, 3 H's. Let's not do H's because H's, there's too many H's. We could do P's, 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 and P. Okay, let's do the O's. So for the O's, here I have 4 O's and here I have 3 O's. So I'm going to put a 4 here and a 3 here. And now what I will do, I'll do my P's. So here's 4 P's, here's 3, let's make 1 here. So that would balance my equation. The coefficient for H3PO4 is 4. Okay, which property is always conserved during a chemical reaction? Okay, mass is conserved. We just know the conservation of mass. The pressure, the solubility, the volume, that depends on what particles you have and how many you have, but the mass, it's going to be the same particles, just rearranged during a chemical reaction. 84. What mass is produced when 245 grams reacts with zinc metal according to the equation below? Okay, this is a stoichiometry problem. Okay, this number, we're going to use that as conversion. That's going to be a conversion. Okay, what mass? That's our desired. That's what we're looking for. Okay, what's my given? 245 grams of sulfuric acid. So this is what I start with. Now I'm going to go from grams to moles. And luckily they give us this number, 98.0. And then I use my balanced equation, and I'm going to go from moles of H2SO4 to moles of SO2, that's my desired. And for SO2 the number is 1, and H2SO4 the number is 2. Those come from the balanced equation right there. And the last thing is what mass, so I need to go from 1 mole of SO2 to grams of SO2, and again that number is given for is 64.0. And when I do this whole problem, so the grams drop out, moles drop out, moles drop out, and left with grams, 245 times 64 divided by 98 divided by 2. And the answer comes out to be B. You just do that with your calculator. Okay, 85, at STP. Okay, at STP means you're probably going to use 22.4. How many liters of oxygen, so this is our desired, of the oxygen gas, react with 4 moles of pH3 according to this equation. Okay, so my given is 4 moles of pH3. And since we're starting with moles, then we're just going to go from moles to moles. So moles of pH3 to moles of oxygen, which is O2. And in the balanced equation, I can see that's a 6, and this one is a 4. And I don't want moles, I want liters. So for every 1 mole of O2, I have 22.4 liters of O2. So moles cancel out. So I have 4 times 6 times 22.4 divided by 4. So I can actually cancel those 4s. So I need an answer that's 6 times 22.4. So something a little bit larger than 120. So I think my answer is actually going to be, well, definitely going to be either C or D. And it's C. Okay. How many moles of FeS2, okay, that's our desired, are required to produce 64 grams of SO2, that's our given, that's a G, according to the balanced equation. So I'm going to start with 64 grams of SO2. I'm going to go grams of SO2 to 1 mole of SO2. And just up above here, we were given SO2 is 64 grams, so I still remember that. Okay, and from my balanced equation, for every 8 moles of SO2, I'm trying to get the FeS 4 moles of FeS2, and that's what I want to do. So I have 64 and 64, they cancel out, that's nice. 4 over 8. Okay, 4 goes in here one time, 4 goes in here twice. So my answer is 1/2, okay, which is the same thing as 0.5. That's answer B. That's good. Okay, 87. In this half reaction, okay, so what's going on? Zinc is going from 0 to 2 plus, okay, and so it's going to get oxidized. And I know that because its charge goes up, and it is losing electrons. Electrons are giving off. It's losing electrons. And we can also say that's Leo, the lion says Gerd. Losing electrons is oxidation. So zinc is oxidized, so we can get rid of those two answers. And it's oxidized because it is losing electrons. That's the answer right there. Okay, during the ornament lab, hydrogen gas was produced according to the following equation. Okay, which chemical was oxidized? Well, here I have, I'm going to rewrite it here. Now again, this one's a little bit of a problem because we don't show the charges. This one has 0 charge. This one in a compound is +1 and -1. This is +2 and -1, and this is 0 charge. So whose charge is getting higher? Who's being oxidized? And it's the zinc. Zinc is going from 0 to +2, so that's the answer. At winter break, we made a chemist's tree using this reaction. Okay, copper is blanking electrons and being blanked. Okay, the copper is going from 0 to +2. It is being oxidized. It is losing electrons. Okay, and again, this is losing electrons is oxidation. Leo the lion says grr. So losing electrons is oxidation. And the last question, when we reacted silver and potassium to form this and this, blank was oxidized. Okay, so here we're saying this is a positive and negative ions, they are changing partners. The silver goes with the chromate and the potassium goes with the nitrate. Okay, nobody is getting oxidized during that. Nobody is changing their charge, they're just switching partners. So nothing, this is not a redox reaction. So double replacement is not a redox reaction. And that's the whole test.